Hello friends, welcome back to my channel TechnoRays. Before going into the next concepts of natural language processing, please like and subscribe to my channel and click the bell icon to get new video updates. In this lecture, we'll discuss about types of parsing. So you can just refer to my previous lecture to get details about parsing. Okay. So there are two types of parsing. First one is shallow parsing and second one is deep parsing. So what is meant by shallow parsing? So this shallow parsing is also called as chunking, which is a type of natural language processing technique that aims to identify and extract meaningful phrases from a sentence. So in our previous videos, we saw what is meant by phrase and how to extract phrases from a sentence, or how to identify different phrases present in a sentence. So if you take this full parsing, in full parsing, it mainly involves analyzing the grammatical structure of a sentence. So it will completely analyze the structure of a sentence, whereas shallow parsing, it only focus on identifying individual phrases or other name of phrases constituent. So it will identify either individual phrases or constituents. These phrases can be either a noun phrase, verb phrase, or prepositional phrase. So what is difference between full parsing and shallow parsing? Full parsing, it just analyzes it analyzes grammatical structure of a sentence, whereas shallow parsing, it just focus on individual phrases in a sentence. So shallow parsing is considered as an essential component of many NLP tasks. So we will use it in information extraction, text classification, and sentiment analysis, which are main applications of NLP. And one more important benefit of shallow parsing is efficiency. If you take this full parsing, it involves analyzing the entire grammatical structure of a sentence. So if you take, or if you want to analyze this complete grammatical structure, then it will be computationally intensive and also time consuming process. Whereas shallow parsing, it involves identifying or extracting only important phrases. Okay, only important phrases or constituents. Because of this, the process is quite faster and also more efficient compared to full parsing. So this makes shallow parsing particularly useful for applications that require processing large volumes of text. So in some applications, we need to process huge amount of text, like either web crawling, document indexing, machine translation, etc. In those applications, it is better to consider shallow parsing instead of full parsing, as shallow parsing takes less amount of time by focusing only on most important phrases in the given sentence. And shallow parsing, it mainly contains several steps, some important steps. The first step is sentence segmentation. So here in sentence segmentation, first the sentence is divided into individual words or tokens. So here, whenever sentence is given, it will be divided into multiple tokens. And then after division, tags are assigned to every token in the sentence. Okay, so we'll be using part of speech tagging where each token is assigned grammatical category. So we are going to assign noun, verb, adjective, etc. POS tags to tokens in the sentence. Okay, so once the tokens have been tagged, then you need to identify and extract relevant phrases from the sentence. So what is step 3? Once the tokens are assigned, then identify and extract relevant phrases from the sentence. So this is mainly done either by using pattern matching or machine learning algorithms. Okay, so this extraction of relevant phrases, that task will be done by using pattern matching or machine learning algorithms that have been trained to recognize specific types of phrases or constituents. And one of the most common types of shallow parsing is noun phrase chunking. So this noun phrase chunking, it involves identifying and extracting all the noun phrases in a sentence. So noun phrases, they typically consist of noun and it can have adjective, determiner or any other modifiers. So this we saw in our previous videos, right? So how we wrote noun phrase? Noun is nothing but it is a combination of determiner plus you can include adjective based on the given sentence followed by noun, right? So it typically consists of noun, adjectives, determiners, or modifiers. For example, if you take a sentence, the black cat sat on the mat. Take the sentence. So here the black cat sat on the mat. So find out different phrases in this sentence. So here the noun phrase is the black cat, right? Because this is having determiner, black is an adjective and cat is a noun. So it can be identified and extracted using noun phrase chunking. So we need to extract relevant phrases from the sentence, right? So using noun phrase chunking, first we are extracting noun phrases in the given sentence. And after that, second step is you need to find out verb phrases also. Check whether there are any verb phrases in the sentence. So verb phrases, they typically consist of verb and any combination. Like it may have adverb, particles, complements, etc. It may have noun phrase also, verb followed by noun. So what is verb in this sentence? So sat is verb, right? So you need to identify verbs. So let us take another example instead of taking the same one. For example, sentences, she sings beautifully. So what is verb phrase in this? Sings beautifully, right? So this can be extracted using verb phrase chunking. Okay. So in this way, we need to extract or identify relevant phrases from the sentence. That is done in the step 3. Then shallow parsing is used in various applications. You can use it in text classification, sentiment analysis, and name entity recognition. And this is one example of shallow parsing. So how to use this? So this example, it clearly says that here you can see we have the sentence, the fox ate the chicken. So in this sentence, the fox give you noun phrase, determiner followed by noun, right? Then ate, ate is verb. And then we have determiner followed by noun, which is again noun phrase. So if you combine this verb plus noun, it gives you verb phrase. So this complete one is nothing but S, which is sentence. So you can take one more example here. We saw the yellow dog. So in this case, first identify different tokens and chunks in the sentence. So first task is, what is step 1 in shallow parsing? First you need to convert or first Part is sentence segmentation, where the sentence is divided into individual words or tokens. So here that division is done. So we, that is one token. Saw is another token. Then the, another token. Yellow, dog, right? So first step is done. So divided sentence into multiple tokens. And step 2 is assign POS tags to every token in the sentence. So POS tags are assigned. For we, it is preposition, verb, determiner, adjective, and noun. Second step is over. Third step is once the tokens have been tagged, next step is to identify and extract phrases from the sentence. So find out phrases here. So this complete part, this is a noun phrase. And here, noun phrase is nothing but you can take determiner, adjective, and noun phrase. So this is noun phrase. So like that, you can divide the words into or a group of words into phrases. So this is one example of shallow parsing. Next, coming to applications. So here in text classification, this shallow parsing can be used in order to extract features from the sentence. So using shallow parsing, we are extracting features from the sentence which are relevant to particular classification task. Like it can be either identifying the topic or author of a document. Similarly, in sentiment analysis, shallow parsing can be used to extract opinionated phrases or sentiments from a sentence, whether it's a positive sentiment, neutral, or negative sentiment from the sentence. And the last one is, or one more example is named entity recognition. So here also shallow parsing can be used to identify and extract named entities. So what are named entities here? They can be either people, organization, locations from a sentence. So shallow parsing, just now we saw it is also called as chunking. It is a natural language processing task that involves dividing sentence into meaningful phrases. So we have some common algorithms for shallow parsing like rule-based chunking, or you can use hidden Markov model or conditional random fields, support vector machines, or else maximum entropy Markov models, etc. Right. So these algorithms, they are not exhaustive, and there are other approaches to shallow parsing as well. And then, so you can use pattern library in order to extract meaningful chunks out of sentences. So this pattern library also, it uses shallow parsing for extracting meaningful chunks from the sentence. See this program. So here we have sentence like this. Pattern library can extract good chunks from a sentence. So first you need to import parse-tree from this library pattern.en. En represents English. Then here we need to generate parse-tree, right? So for that, we imported parse-tree. For that function, you need to pass the sentence which we considered here. So that a tree will be generated. And now for node in tree, so pick the root node. Root node is nothing but sentence in NLP or in parsing. So for chunk in node dot chunks. So what are node dot chunks here? So this sentence should be divided into multiple chunks. So pattern library can extract good chunks from a sentence. So in this way, we need to divide. First, you need to divide into phrases. So that's what we saw in shallow parsing. So after division, we need to pick. So this becomes node dot chunks. So these are multiple chunks in the given sentence or multiple phrases. Now you need to pick every chunk from this node dot chunks. So pick the first chunk, that is pattern library. So print chunk dot type. So print type of that phrase. So what is pattern library? This is nothing but noun phrase. And after that, you need to print word dot string. So that string is pattern. So here you need to represent pattern separately as well as library separately, two words separately. So first we are taking pattern and the POS tag assign it to that word. We'll print that and then we'll go for, in the same way, we'll print this word dot string. So this chunk type, so if you see this output, you can see this clearly. So chunk type is same because we have a single chunk, right? But we are printing string and POS tag separately. So noun phrases pattern library. So we are taking this as noun phrase. We are printing that only once. And then word dot string means pattern. And here tag or the tag assigned to that word pattern is noun. Similarly, take the second word, that is library, and it is also noun. Okay. So then, so what is this U here? So U is nothing but it's a prefix before this string pattern. So it denotes that it is a Unicode string literal. So Unicode is a standard for encoding characters in a way that can be understood by the computers. So this will appear before all the strings and POS tags also. In the same way, you need to repeat this loop until we reach end of this sentence. So what are the different phrases we got from this sentence? This is noun phrase and can extract as verb phrase, good chunks, noun phrase. This is preposition, a sentence, determiner followed by noun, which is noun phrase.